All right, here we have section 9.3, which deals with rotations. So there's our main ideas: draw rotated images using the angle of rotation, and then to identify figures with rotational symmetry. Then our vocab over there: rotation, center of rotation, angle of rotation, rotational symmetry, invariant points, direct isometry, and indirect isometry. So lots of fun words. All right, rotation is a transformation that turns every point through a specified angle and direction about a fixed point. That point is the center of rotation, so it's like the point at which everything pivots about. The angle of rotation is the angle between a point on the pre-image and the corresponding point on the image. So you can either be asked to find the angle or be given an angle in order to find the location of a point. All right, so looks like we got our first example here. Rotate parallelogram ABCD 60 degrees counterclockwise about point R. Okay, so to do a rotation of a figure, you're going to need a ruler and a protractor. So step one is we need to draw a line from each corner back to R. So it's going to be kind of tricky to do without getting it all goofy on the focus and whatnot. So there's R to C. R to B. Apologize if it's moving all over. To A. And then, there we go. All right, so there's my 4 lines. So then what you actually need is you need a protractor. And you need to rotate each one 60 degrees. So to protractor, you put the vertex there, the center of the protractor on the dot. And then the line comes off, goes along the ray that you want. So there's A. So 60 degrees, so I'm going to go up here to 60. And then use that to sketch in a line. And you do that for each of the points. So this is the line for A. I'll label it so I know what I'm doing. So this will be 60 degrees. That's the line for D. So now we need the line for B. That's the line for B, and then one more for C, which is actually on the exact same line as A. So we'll call that A and C. All right, then you have to make some measurements. So we'll use the centimeter sign. So for D, distance from R to D is 3.3. So then you come over here, 3.3. Put a lovely little mark, and there is D apostrophe. And you repeat the process for everything. So for, stapler's on the way here. So for A is 3.4, so we'll come out here. 3.4, so there is A apostrophe. C is on the same line, and it is 1.1. So 1.1, and then for B, that's 2. Call it 3. No, not 2.3. 2.8. And we come on B and go out 2.8. So then there is B. So then that's C. So connect your dots. And there's the figure rotated 60 degrees. So that kind of got off a little bit, but so steps once again: draw rays or lines from each corner back to your point you're rotating about. Use a protractor to then do whatever angle it tells you and draw new rays out, and then make measurements that you then copy onto the actual ray itself. So measure the distance from R to B, and then use that to go from R to B on the new B ray. Okay, the other part of this deals with what's referred to as rotational symmetry. So if a figure can be rotated less than 360 degrees about a point so that its image and pre-image are indistinguishable, then you have rotational symmetry. So here you have a pentagon. It has rotational symmetry because if I rotate this one step over, there is no visual distance if you eliminated the numbers between this pentagon and that pentagon. And then so this one you keep rotating where the 1 is. So there are actually 5 different versions of this. It's like a square, for example, would be 4, because there are 4 identical corners. Hexagon 6, so on and so forth. So example 2 down here, identify the order and magnitude of each symmetry in each part of the quilt shown on the right here. So the large star in the center of the quilt, this one's kind of tricky because it's hard to see the number of points, but 1, 2, 3, 4, 5, 6, 7, 8 points. No, I think there's 10. Start at a different place. We'll start on this guy. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 is that one. Entire quilt, so you're looking at the corners, so since it's a square, there are 4 identical corners, so it'd be 4. And that's the end of this section.